BYP out in a rainy yard. It's almost antenna season. But redoing the video on the low thin wire 8075 dipole. There's the feed point. SO239, 2 pieces of wire. Runs down a stick that I cut from a small tree and shoved in the ground. The other end about 65 or so feet that way. And there at about 6 foot height is a 20 gauge enamel coated wire. Don't use bare copper, it'll corrode. But a piece of tape to mark off 10-foot increments to accurately measure the length. And at this end, a cheap $1.50 rocker switch and additional length of wire. And I'm standing in water and it's cold, so I'm going to come back inside, and there's a pole. That additional length of wire and switches on each end. The switch is thrown to lengthen the wire for the lower end of the 80 meter band at 35035. Open both switches to shorten the length to 3875, and close one switch and open one switch. And it's not a perfect SWR, but it's a very good match in the middle of the extra class phone segment. And it's 6 feet off the ground all the way out. And in the ham shack where the weather is much more inviting, a schematic of this extremely simple ultimate portable antenna with both switches open or closed, absolutely perfect resistive match. Ultimate portable antenna, small, weighs nothing, handicap accessible. Someone in a wheelchair with a fairly firm yard can make and install this. It's an SO239 panel mount socket. I guess you could also use one of the round ones without the flange. It has a solder tab, but the left side wire is to the center conductor. Wrap that wire around the center pin instead of in and bending it, because it'll be less likely to break. And obviously solder or get a ring terminal and connect the other wire to the shield, to the flange. If you had to, you could even do away with the connector, but it's less convenient. Nice thing about the connector is it allows inserting a small SWR meter at the feed point, and build this and do that and get it match just right, and then try it. Say it's an 80 meter, try it on 40. It'll be out of match. Put a so-called tuner at the transmitter and get it where it looks like it's tuned, and then go out and see what the SWR is at the feed point. I guarantee you it won't be tuned. The switch is just any cheap $3 switch. There's essentially no current. The wire diameter is what creates, so to speak, the 50 ohm feed point. The height above ground and the wire diameter are what cause that. Eliminating reactance at the feed point is done by having the wire straight in line and the same height all the way out. To calculate the length exactly for the exact frequency to the couple kilohertz is done by finding, with reference to the speed of light, the length of each of those quarter wavelength arms, quarter wave long, at, let's say, 3.9 megahertz, whatever frequency you want to pick. But pick a frequency, and for that frequency, assuming free space in a vacuum, the electromagnetic fields along those wires will be traveling at essentially the speed of light. And the other video on this antenna, the previous video on this YouTube site, on my YouTube channel, has a link to a website with a calculator that you can do that with. It gets a little clumsy trying to write out 6 digits of the velocity of light. But let's say that at 3.9 megahertz, which would be with the switches closed and the antenna arms longer, let's say that length is 68 feet. That's the velocity, at the velocity of speed of light in a vacuum. That would be the time corresponding to a quarter wavelength at that frequency. And that website has everything you need to calculate it. You just have to figure out how to plug the frequency in. It's not difficult. It's just multiplication and division. But that in practice will be too long because the energy is traveling through air against the ground. So the correction factor for which to figure the exact length of that wire to the tiny fraction of an inch, and both must be exactly the same length. That factor is 0.951 times the speed of light. That indicates that the wave velocity has slowed, and realize those dipole arms are transmission lines just as certainly as that coax coming up is. But that 0.951 factor allows absolutely precise length. Connect the two wires at the coax socket, stretch them out in parallel, make them exactly the same length, cut them at the same time with the wire stretched. You might need to connect the feed point, the SO, to something to hold it and pull the wires taut. But this antenna, as I have built it, is out there. There's the near end at the metal pole I showed you from the back door. But it goes from there out to center of the frame, that stick stuffed in the ground, center frame, and on past, and the wires aren't straight in line. The end towards the house is curved, is bent towards the right of this video field. So I would have to take that metal pole and move it, but I've got no place to move it to. So it's pretty close. But that antenna has a 3-to-1 SWR at 330 kilohertz wide. No such thing as a tuner. You'll be able to work 50 kc with almost no indicated SWR. It's an amazing antenna. I've worked easily Maine down to Texas and Eastern Europe, the Y01 GGX, I think it was, on that antenna. And it's amazing how well these antennas work, these dipoles, when they are perfectly matched at the feed point. No compromises, because compromises mean all the power is not emitted. And also there's proof through IEEE Antennas and Propagation Society that the feed point resistive value is related to the emission pattern. So that implies if the feed point's not right, not only is all the power not going to be transferred forward to the antenna and emitted, but it's going to screw up the pattern. And almost every other station I work with, a poor end-fed, off-center fed G5RV, have poor signals because the signal's scattered, and their signals are subject to fading, and mine isn't, and they just can't believe it. Your signal sounds like, I worked N4JEH this morning. She said, it sounds like you're running a kilowatt. I said, no, I'm running 60 watts. And your signal's not fading. Yeah, it never does. So for the wire is plain. Get hard drawn wire if you can. It doesn't kink as easy, and it'll pull up straighter than the soft drawn wire. It doesn't want to sag as much. But be careful when unspooling it because it can spring out. But it's just 20 gauge magnet wire. And this is it. I'm sorry, this is 22. Get 20. 22 should work. But this is the type of wire. Extremely inexpensive. SO sockets, $3. I don't know, $20 for a small spool of wire. You'll need 150 foot for 80 meters. This will also work on 40. So once that's set up for example, for the 80 meter, then calculate the length of the arms at 40 meters and put a switch closer in. That 40 meter length for each arm will be about 35 feet. So ideal antenna. If you want a real multi-band antenna that is perfectly matched, this is it. You'll never get there with coils. You'll never get there with traps. They're a compromise. They're reactive off frequency. A trap only works on one band and they're narrow. On other bands, they're reactive and they screw up the antenna. So no compromises, no traps, no gimmicks. $3, $6, $9, $15, $25 plus a stick. You can't beat it. Rolled up around some kind of plastic form and take it camping with you, and you'll have a bodacious signal, even portable. KBYP.